So this talk is about Trustix, a new model for trust in binary software distribution. So first, I would just like to introduce myself a little bit. I'm maybe not in this exact order, but I will start. I work at Twig.io, one of the co-organizers of this conference. We are very heavy into Nix and Haskell, so our involvement in today's event is mostly around our interest around Nix. But of course, packaging is an exciting ecosystem anyway. So there's a lot of other interesting talks that are not Nix related here. I maintain Emacs plus the entire Emacs infrastructure in Nix packages. I kind of ended up as the de facto maintainer of that, and author of various to Nix tooling that you might have used or not. The most famous one being Poetry to Nix. I co-organized NixCon when that happens as an in-person event, and I've had Nix packages commit access since 2017. So this is just to show you kind of like I'm not new to this community, and I kind of have some credentials there to talk about this kind of things. And before I joined Twig, I worked as a blockchain engineer for a blockchain consulting company, which is kind of like where this intersection of trust and package management comes into play. So first things first, let's talk about what problems we're trying to solve, and then we'll look at each individual component of the solution. I will present you Trustix, my kind of ideal solution and reference implementation that we have been working on. And I'd just like to give some acknowledgement to some people that have helped along the way, and then we're open for questions. With the traditional packaging trust model, you might think it's very simple. You just go and you say, hey, I want to install OpenSSH. How do I do that? Well, I download a package index. I get an OpenSSH entry from there somehow. I go through that level of indirection, and then I end up fetching an archive. I have a local keychain. Either that might be a GNU PG keychain, or it might just be as simple as a list of keys in a text file somewhere, as is the case for Nix. I think Debian has some more complicated GNU PG around this, but essentially it's the same thing. It's kind of like this central entity holds something very secret in there and signs off on that this is all okay. So this comes with some notable problems, most of which stemming from the fact that you have a single point of failure. You're trusting a single entity to provide you with full trust. Like you don't have any. If the Nix binary mirror would someday start misbehaving, you don't really have any option to go and like say I want to put my trust elsewhere. Not that I'm saying that it's misbehaving, but it's kind of like that's the model of it. So you have no guarantee that the source code you actually wanted to execute actually mapped to the binary outputs that you had or that someone provided you with. So that's the problem when we are trying to solve here. Distributing trust from single parties to multiple parties. And don't just move it around. Don't just like move it from one organization to another, but think about how do I put my trust in everyone and no one at the same time. This work took heavy inspiration from transparency logs, such as the work happening in the SSL ecosystem in terms of certificate transparency, revocation transparency, just generally blockchains and so on. So if you're kind of into this kind of verifiable data structures kind of thing, then that you will recognize a lot of things from the verifiable data structures white paper from Google and so on. But the idea is to let anyone that wants to provide build their capabilities, and then it's up to me to decide who I want to put my trust in, not up to some central repository. So first things first, let's look a little bit at Nix, and not in too much detail, but just say that it's a source-based package manager. So you have source-based expressions on that you use to create your packages. So these are written in the Nix language. Packages cannot have any unspecified input, so no dependencies that are not there. You cannot accidentally depend on a library which was not specified at packaging time. Every single time a new sandbox is created and that package build happens in isolation, so unless something is specified, that sandbox won't have it and the build will fail. And this is very important to build such a system, I think, because it gives us the unique property that the traditional package managers don't have, which gives us a unique build ID per package. And that is the same build ID for both me and you. It doesn't matter if I build it in a year, 5 years, 10 years from now, that build ID or store path will be exactly the same. The output won't necessarily be the same, coming down to reproducible builds, but the build ID and the paths on disk involved are exactly the same. And then these expressions are compiled into pinned build recipes where they're not human readable anymore. They're for the build sandbox to pick up and build. And that is just to help you a little bit with the with the concepts involved. I hope it's clear. I didn't want to go in too much into Nix because it's a massive rabbit hole that can take a very long time. And it's not particularly interesting in terms of what we are doing here, because what we are doing here is something much more generic, applicable to a lot more. So let's look at the other underlying technology, which is transparency log. So these are signed append-only logs. You can only write data to them, and as long as you have distributed them, you cannot rewrite something after the fact without that being discovered and the whole tree being invalidated. So this is obviously important for a distributor of software to not be able to say after the fact that no, I never built this, or actually this hash has now changed. Well, you can still do that in this system, but at least it will be detected and seen as an invalid transition. So it's not possible for any vendor to lie anymore about like, no, I never built this or anything like that, because they can only present you with the entire truth, or you will discover it. So we're using two kind of hash trees, Merkle trees. One, for the lack of a better word, I call traditional. One called sparse. These have quite different properties. We combine the two to get the properties we want. We'll talk a little bit more about those in a second, but it's the basics. And this allows for partial verification of very large data sets. So even if a log has had 1 million entries since you last read it, and you want to get up to date, that's only about 50 or so verifications to jump 1 million entries. So you can see how efficient it is and how important that is when we are building in the order of 1.5 million builds every month on the NixOS CI Hydra. So this is obviously something we might even want to run on mobile phones at some point. So being memory efficient and not having too much data transfer is very important. And yeah, so So what can we do with these magical trees? Well, we can with the traditional one, we can efficiently verify inclusion, so we can prove that this package that we want to look up, it was indeed included. We can also verify that it was not included in a collection. We can detect split view. So if one builder tries to lie to us only, we can detect that by cross-comparing not only the logs, so not only the build results, but also the builders. So builder B says builder A has this state right now. It cannot roll back on that because we've already seen that through builder B. So we can detect that this builder A gives us a completely different view of the world than it does other people. You can verify that it's append only, and the future we're seeing is consistent, and then everything is good. We can walk the entire data structure. We can verify every single entry that was added. And we don't need, like I mentioned before, this is the one where we can do 50, where 1 million entries roughly becomes 50 lookups instead of, well, 1 million lookups. So kind of simplified, but this is how you build these trees gradually, incrementally from left to right. And if you would want to audit any particular, so imagine these nodes that just say hash being packages, or these entries being packages. And then as you go up the tree, you need to verify less and less. So in this case, we want to verify this entry 3, which is a package. And we want to verify that this is indeed consistent with this hash. So to do that, we don't need to walk every single entry. We just need to look at this node, and this node together to verify it. So you can see how as we grow, this becomes more and more efficient, actually. Not in absolute terms, but in relative terms. And we can check two kinds of, we can verify 2 types of things with this. One is indeed the log of build results was not rewritten, and we can verify that it was consistent with what we perceive the remote state to be. I notice I'm running a little bit lower on time, so I'm going to speed up a little bit. But these sparse Merkle trees are also very important because they are the ones that allow us to do kind of key value lookups. These are a much more complicated structure of an uncomputable size. We cannot enumerate these collections, so it's not possible for us to walk the whole thing and verify that every single entry was intact, because we don't have any way to iterate over this 2 to the power of 256 big data structure. So we combine these 2 data structures to form one append-only key value store that we can that gives us all of these properties combined. So we can prove that a package was published. We can prove that it was not published. So no one can lie to us in either way, like I did or I didn't build it, and they cannot change anything after the fact. And once I know that this head over here has this hash, and when I say head, with that I mean like this logs latest submitted entries. So when I have this hash of that, we can get a key for an output for a package, and prove that no one lied along the way. And again, we can prove append only and prove that the map is behaving correctly, but that is inefficient. Regardless, this is the best we can do with what we have here. So now we get to the part which is my actual project and the project we've been working on. It's a reference implementation of this concept we like to call build transparency, which takes, like I mentioned before, these Nix expressions, which are like perfectly human readable, and then turns it into a build recipe, which so the whole process here is like end-to-end transparent, and that's how we can ensure that trust is properly maintained throughout this, because we can cross-correlate these independent parties according to what I think is correct and who I trust and to what degree. The current implementation is built on top of Nix. It can be extended to others. We're currently looking into doing it for geeks as well, which is semantically very similar. So it should be like semantically compatible, but of course there's going to be a lot of geek specifics to figure out there. So this is what happens when you download a package in this model. So instead of going to this mirror and say, hey, give me this thing, and then I verify it against a well-known good key, what I actually do is I go to every single builder I know of and say, does any one of these have this? And then once I've collected what everyone thinks about this particular package and what the correct state of that is, only then do I make a decision and select an output. So even if one of these is having a different result from the other ones, I can still skip the build and download the binary results. So it's kind of built in that non-reproducible builds are kind of discarded, and that's a normal part of the flow. And then you will just end up building these from source locally. So the user flow, like how do I use it? How do I find logs I'm interested in? Well, this is not a blockchain. It doesn't have a concept of global consensus. So you're going to have to figure out who to trust and to what degree yourself. Of course, there's some code support for this that makes it easy to add builders. But at the end of the day, this is all about empowering you to decide who you trust. So it's not going to be something that just works out of the box and gives you absolute trust. You're going to have to do some of the legwork yourself in regards to deciding who to trust and how much. And you can do that via custom scripts, or you can do it via one of the built-in shipped kind of predefined engines for that, which some can be either qualified majority, or it can be a minimum number of builders that reach that result, and so on. You can see it's kind of like it's a framework for you to decide decide what you trust. But we aim to have sensible defaults. So while it is a framework, you don't have to build everything from scratch yourself. This, I think, is a bit technical, and we're running low on time, so let's just skip it. What is the current state of the project? The initial phase is done. We have a 1.0 alpha tagged, and that doesn't mean that we are feature complete or anything like that. It just means that the APIs and the data schemas, they won't break. The on-disk schemas won't break. So the data format and APIs are stable, but the internals are not guaranteed stable, and the CLI is not guaranteed stable quite yet. Phase 2 is initiated. We have a bunch of interesting stuff coming up, especially in terms of how to skip a lot of verification and do a lot less work to doing that. And we also have web-based tracking dashboards, so you can, which it strikes me now, it should probably have included a screenshot too, but you can track packages over time and their reproducibility. And of course, anyone can join in and submit these logs. So anyone that has has a few spare CPU cycles can join in and participate in bettering reproducible builds. So I would like to acknowledge some people, and some people more than others. I would like to thank Matthias and Taher at Twig in particular, Twig in general, but those two in particular. I would also like to thank the Trillion team at Google, who I talked to about this project early on, who gave me some really good pointers, and just generally thanks to everyone involved and interested. And last but definitely not least, this was all funded and made possible by the European Union via the NLNet Privacy and Trust Enhancing Technologies program. So if you have great ideas and you are looking for open source funding, I think you should definitely look up those guys. And I'm kind of done and open for questions. Sorry, I believe you're muted.
Thank you. Just look at the chat. One of the questions I had was, how have you thought about how users would bootstrap that initial trusted collection of builders? If I came into this project new, like, how would I know which builders I could start trusting?
So right now there isn't a whole lot of adoption, but the idea is that the modules so the NixOS modules, the configuration modules that comes along with this will have, maybe you can just say, I want to trust Twig, and then that's a one-liner option that you bootstrap through the module.
Okay. We have another question in the chat. Have you thought about rebasing this work on SigStore instead of using the current transparency log implementation?
Yes, I did. They don't quite have the same scope and data structures they use, from what I've seen. I looked. Trustix actually predates SigStore by a bit. I don't think they have the sparse Merkle tree support, for example. And I just think that having ownership of those data structures for the particular use case actually makes a lot of sense, not only from kind of like simplicity, but also from performance perspective.
Thank you. Are there any more questions? Just going to look real quick. Yep. All right. Well, thank you very much for that talk. There's one more question. Have you considered how fraud proofs might be worked into this system?
No, I have not thought about that.
Okay. Can someone, I guess this goes back to my initial question, can someone submit an initial set of pre-built hashes to jumpstart the store?
Yes, there is some CLI tooling in there to say, I want to submit this entire package. I don't care if I built it locally or not. So yeah, there is tooling included to submit stuff, even though you're not building it right now.